Hello and welcome to Innovation Day, Digital Resilient Transformation. First of all, I want to thank all of you for joining this session. In the morning sessions, you would have gone through a lot of discussion covering various topics. Example, digitizing data center, powering data center, the future of innovation. We have looked at technology landscape and what the IT landscape looks like, a more futuristic discussion, and intuitive industry, and many more. This topic, we are going to cover Industry 4.0 and IT OT convergence. My name is Nikhil Pathak. I'm from 슈나이더일렉트릭, and I'm going to be moderating this panel. And it's going to be a very interesting discussion. But before we start discussing different topics, I would like us to take back a little bit in past and refresh and travel the path what humankind has taken while we had undergone the industrialization. So let's start with what we call Industry 1.0. Industry 1.0, late 19th century, we have looked at the use of steam engines and what it can get us as a part of the industrialized environment. Then we moved on to Industry 2.0 in 20th century, talking about mass production and more robust organized manufacturing processes, which really helped us to produce at scale. Same century later part, what we call an information era. We started using a lot of information, and I would call it Industry 3.0, which provided us what we know as automation journey. And that's where we started an automation journey. Come to Industry 4.0 in today's presence era, which is connecting IoT with manufacturing processes. And that's, I would say, a biggest technological transformation which we have seen when we talk about industrialization. It's not about only manufacturing processes, it's about the entire ecosystem in which we operate. We have learned a lot about smart factories, smart manufacturing. We know about what we call dark factories, lights out in a factory. Right? We talk about artificial intelligence, machine learning, self-healing processes, and much more. Just thinking of how do we make this happen. We are today just collecting so much of data and analyzing it, and all this data actually is being generated on a shop floor. We are collecting it there and we are analyzing it, which is helping us for some really good actionable insight. It's providing us lots of intelligence. And that data has so much of a power to drive what we call a huge transformation for Industry 4.0. But not only, and everything revolves around data. There's much more beyond data. I think we are looking at the enablers, which is an entire ecosystem. So now, that's exactly the discussion. We know that the data is so important. The industrial age is a big enabler for analyzing, collecting this data and taking some actions. But beyond that, there's a whole ecosystem, and I'll keep using this word ecosystem because that's most important when we talk about IT-OT convergence, right? So that's the discussion which we are going to have it today. We have a stellar panel, stellar speakers with us, each one of them having a very good experience over many years in this field of IoT, IIoT, and let me first introduce our panel. I would like to introduce first John Vicente. He is Chief Technology Officer at Stratus Technologies. John is Senior Officer and Chief Architect at Stratus Technologies, and he is defining and evangelizing the strategy at Stratus with a focus on Edge and IIoT. Then please welcome Trip Parton, Chief Technology Officer for Converged Servers, Edge and IoT System at Hewlett-Packard Enterprise. His primary responsibility is to drive technology strategies of a roadmap and partnership plan across business unit portfolio, with a focus on Edge and IoT. Last but not the least, welcome Jared Campbell, who is Director for Strategic Alliance Marketing at Aviva. And as all of us know, Aviva is a global leader for industrial software. Jared has over 22 years of experience in applying and marketing industrial automation and software in different industry domains, starting with semiconductor, machinery, oil and gas, chemical, power, and infrastructure industry. And he holds more than a dozen patents in the manufacturing and industrial automation fields. So to all three of you, thank you for joining this panel discussion. So let me start with the first question, and the question is for you, John. You have been pretty close to customer. Your team is close to customer as a part of the chief architect. With Industry 4.0, how would you see from a customer perspective how they are evolving in defining their processes, the ecosystem, customers' demand to make things happen once again, right? So just your perspective, if you want to kind of share with all of us.
First, thank you, Nikhil. For context, I want to talk about my perception and vision of this transformation. And then I want to give a perspective on the vantage point on the transformation from the customer's point of view, and then specifically get into requirements on that transformation, their requirements. And that really depends on the customer and their current situation. And so I want to really set up that context. So I'll start with my first slide here. In my view, Industry 4.0 and edge computing are somewhat synonymous. And they're essentially headed to the same end state. And that end state, in my opinion, is autonomous systems. So if you think about that end state and look at where we are today, I refer to that in this roadmap here, if you will. This is a high-level view of technology evolution for edge computing. It's about connected. We're in the secure, managed, and connected stage. It's the beginning stages of convergence. Over the next few years, we'll move more into open software defined and eventually reach convergence, where I refer to that as Edge 3.0 or real-time and resilient. So that's my view, my perception of what this transformation looks like. So with that in mind, going to my next slide here, Stratus has developed what we call a maturity model for edge computing, or the 5 I's. Isolated, informed, insightful, intelligent, and visible. And if you look at the bottom here in terms of the technology evolution, it maps somewhat to what I presented in that roadmap slide. But this view is more from the vantage point of the customer adoption, and readiness. And as you look at different companies, very similar to the IT industry, there is really a spectrum of adoption and readiness and maturity of these companies, and customers are recognizing that. So I think it's important, as we start to look at customers, understanding where they are in terms of this maturity is important, both from a capability perspective as well as processes, and I would say as well the human aspect. So you see this evolution happening and this maturation process, it's important to understand where customers are and where they're headed to. So without getting into more detail on what this table is showing, what's important here is to understand the customer, understand the journey that they're going to pursue, and be able to map the technology and the evolution of technology and the capabilities necessary to their specific needs, their use cases, and what they value in their environment.
Thanks, John. I think a very, very interesting perspective what we started with after hearing from you. That leads me to the next question, and we talked about software. And the question is for Jared. Software is a key enabler, no doubt about it. But what we would like to know is a play of software, how and why, in the solution architecture that we provide to our customer.
Sure, thanks. So when we think about software in the Industry 4.0 context, I think it's important to think about a couple of things. Who needs access to the data? What are you doing with the data? And are there any special requirements around time, speed of execution, data storage, and security? And so when we think about all of those things, we at Aviva look at the sort of the edge to enterprise story, is what we call it, which is we start at the machine and think about at the asset location. What is the data we want to connect and collect to? Do we need to visualize it there? Do we need to make decisions at the machine? Or do we move that data up to maybe a higher architectural level in the control room where we're going to operate the overall plant or facility? We're going to analyze the data. And kind of the conventional idea of the control room is still there. But now we're able to move some of that functionality, I would say, to a lower level, closer to the machine, where you can do advanced analytics embedded on edge devices, give operators more visibility, more knowledge about what's going on with the process. And so we kind of have, in the traditional plant sense, the asset location in the control room that we look at. But then above that, we have this concept of the enterprise, which has traditionally been your IT space, not necessarily OT space. And in the IT space, typically you've looked at things like, reporting and dashboarding and how the business is operating. Well, what's happening in Industry 4.0 is we're able to converge using cloud technology, the data from the OT side and the IT side together in that enterprise space. And that opens the door for advanced analytics, machine learning, lots of other tools that we've not had before. The other thing it does is it breaks down silos. So whereas before maybe an operator had knowledge of how his machine was working, but he didn't really have visibility to how all the machines in all the different sites and locations that the company operates is working, and whether his happens to be working similarly or differently from others. And so by using software and converging IT and OT data and building purpose-built analysis, operational tools, and performance tools, we can share data back and forth across the asset, the control room, and the enterprise layer in sort of this comprehensive edge-to-enterprise approach.
Excellent, Jared. I like the reference of the use case what you talked about, and I also captured some words, breaking down silos, cloud technology, enterprise layer, IT, OT, and that actually brings me to the core of the discussion and the core of our topic, and that's about IT, OT integration. So to Trip, the question is for you. How are we making it work, IT, OT integration?
Yeah, thanks, Nikhil. And it was interesting. So as Jarrett was talking about software, started to have flashbacks from earlier in my career when I was working in the software implementation space, and specifically around ERP systems. So if you kind of think back, right, when ERP systems first came out, the problem they were solving is that back office financial accounting type systems were made up of a bunch of individual systems that each did their own job. You had a general ledger system, you had an accounts payable, you had payroll, you had accounts receivable. These were all separate systems that all did very specific things. And the challenge was they were all really centered around the same types of activities, and so you had challenges with interoperability and challenges with groups working together. And so what ended up happening was companies sat back and looked at that problem and said, you know, if we start designing the software so that you have a common internal infrastructure, a common data model even, and I think in this case they centered it around like the chart of accounts, right? And use that as a way to bring all these individual systems together, that was the birth of ERP systems. And then you saw the efficiencies and the insight that was gained by corporations to do their finances that way, and to do their accounting that way, and to be able to report to the street that way, and have much more confidence, because they took all these individualized systems and brought those together in a way, sort of uniting the right factors behind the scenes with the data models, and then allowing what used to be a bunch of independent systems to now work together. And I still see this as sort of the same a paradigm that's now being tackled in the industrial areas, is they have a bunch of individual systems. You know, there's a lot of technology in these industrial areas, in factories, on plant floors, but each of these systems is really solving a specific problem and is built to sort of work on its own, doesn't worry too much about what's happening to the left of it or to the right of it. I mean, if you even look at an assembly line as an example, the assembly line is made up of a bunch of different vendors, each doing individual tasks, and it's really up to the designer of that full system to get the individual tasks in the correct order to actually accomplish everything needed to finish and create the widget that it is that you're creating, right? But none of those systems really interact with each other. It's all a person that's sort of making all of this, or people making all of this work together. And I think if we kind of follow that example that we saw with ERP systems and look to do the same sorts of integrations in the industrial side and leveraging IoT and leveraging some IT capabilities, then we can look for the manufacturing side, the related industrial utilities, etc., to have some of the same gains and successes and increase in insights that we saw, you know, in back office accounting and finance back when the ERP systems first came out. And it's not just on the software side, right? If you kind of look at it, even on the hardware, the way hardware was designed, the way infrastructure architectures were designed, moving from mainframe to client server type systems, these were all done in a way to really embrace this unification on the software side that ERP systems were bringing, but also recognizing that in order to have this many different types of users all on the same system, each of them have different focuses, there's different types of capabilities that are required. They may need peak processing at different times of a month given whatever they're focusing on. And so not just on the software side, but on the hardware side, changes were made to the design of the hardware to really optimize the way these ERP systems would work. And so as we're seeing new software players and new software packages being put together to really help drive some of these same types of advantages now for industrials and utilities and the like, we're also going to see that on the hardware side. And that's been something really that HPE's been focused on, is we've really been taking our years of data center capabilities and understanding what works and the types of design changes and the types of optimizations that we've created, not only for optimization of the software packages we're working with, but also for the manageability and the security of those systems. But when you start to look at industrials or manufacturing or industrial IoT type use cases, you know, how and where those get implemented is very different. So we want to take those 20 to 30 years of expertise that HPE has created, really optimizing the data center, but then start making adjustments in terms of size, weight, power, and temperature of the types of form factors that we take these capabilities and place them into, so that they can be deployed in non-data center locations. They can be deployed, you know, in closets, in plants, in non-data center environments where you don't have as much control over the temperature and the like. and quite honestly, maybe even directly on a shop floor, directly next to the machine itself that it's interacting with, because that's required based on security or latency or regulations or a number of other factors where you really need the right level of compute running the right software packages really right on the shop floor, right next to some of the industrial equipment, so that you can really optimize that environment and start to be able to take some of these same gains that ERP systems brought to the back office 20 years ago and see some of those same effects now with our industrial customers.
Thanks, Trip. That's a very interesting perspective what you provided. So now, if I have to summarize of these three questions and the highlights what all three of you provided in Industry 4.0 perspective, the current state, the requirement, and the challenges what we see today. And from there, I would like to move on to our next topic, which is more to do with ecosystem. And I would say a collaborative IT OT system, because I think that's the foundation, right? I'm talking about collaborative system because that's the foundation on which we are building solution architect. And this solution architect is just to make sure that it covers end-to-end process and that delivers what is intended from the system. So the topic is this IT OT collaborative system, what value it generates for our customer. And the question is to you, Trip, again, while looking at interoperability, I think that's the must for this collaborative IT OT system. How can we get to the next level of competency? And it's to do with the technology and also people. So basically, I'm talking about a full ecosystem.
You know, Nikhil, I think that's really going to be an interesting challenge. And the reason for that is a lot of the players that have been in this space so far are used to designing closed systems. They're used to designing systems that are purpose-built specifically for solving a specific problem. You know, I mentioned earlier when you talk about assembly lines and you've got the different stations that do very particular things. And the same thing in this case, right? These are the players that were building these systems specifically for that purpose. But a lot of times what happened was, in order to sort of guard and maintain their market share, they use very specific protocols. They use very specific ways to communicate with their machinery. So the way you would get into that, to interact with that data, to try to get access to that data was very restricted and very closed. And quite honestly, again, this is not new for IT. This is something we saw 20, 30, maybe even 40 years ago. And if you remember some of the initial computer manufacturers, whether it was a Wang Systems or a Unisys or even some early IBM mainframes, what you ran into is you had these powerful computer systems that were built, but then all of the software was very specific, very proprietary. The operating system, the way that worked, the types of packages you could run on it, you pretty much had to get everything from that same vendor. And so now transition 20 or 30 years later, with the advent of open systems within the IT world, moving to standards like x86, having just a very few operating systems, and even those operating systems still, for the most part, run on the same common hardware infrastructure, the same common chipset layouts. So you have a much more robust and a much more open operating environment to work from. And so the ability now for these systems to interoperate, for the ability for you to be able to start the sharing that IT has developed over the last 20 or 30 years, you're just starting to see that come into the industrial space. And that's one of the reasons a lot of IT players, like an HPE and others, have actually been able to move into the industrial IoT space and start to bring in some of the advantages of open systems. And this is actually something we've been hearing from our customers for a while now. So I'll even use a use case that's not even specific to industrials. So in talking to our telco and Department of Defense customers, you know, that's another set of industries where it's very common for systems to be very specifically built just for that industry, just for the types of use cases that they had, whether it was telecommunication equipment, things that get deployed out to towers, or whether it's ruggedizing ruggedizing IT equipment that the military could then take and use on battlefield or in deployment type scenarios. Well, what we started hearing back from those customers is, while those systems are great and solve the problems they need to, because everything is purpose built, the cost of the systems back to those customers is very high, because they have to absorb all of the R&D that went into those systems. And so just like that, and that was really the case back when mainframes first came out, and again, those Unisys and Wang examples that I gave. So now what happens when you move to an open standard where you've got many more vendors involved, many more customers, many more systems that can be built, what happens is you start to then build a platform that can be leveraged not just for one use case or two use cases, but for 5, for 10 use cases, and not just for one industry, but 5, 6, 7, 8, 9 industries. And so what happens is the R&D for those systems gets spread out across all those use cases and all those industries and all those customers, and your overall cost base for that system goes down. And we saw that happen in IT, over the last 20 or 25 years. And now as IT are bringing some of these same open standards into industrials, into the shop floor, directly into plants, and being able to not necessarily rip and replace a lot of these systems that are currently in place, but being able to leverage new techniques to be able to interact with those systems, leveraging the ability now that the computer systems are robust enough to be able to interact with and interpret those different protocols, translate that data, start to get data into as common a format as possible, and then allow those same kind of benefits of a common platform, of a unified system, of open standards to really come into play, not only to allow you to get to the data that you normally wouldn't be able to get to, but also to do that at a cost factor that's much more easy for these individualized plants and the way that they're used to buying and consuming capabilities and technology, in an incremental solve a problem as you go type of a basis. And so now these technologies can be put into cost factors that allow the plants to be able to do that. Now, if I wanted to push the envelope a little bit, I could say nirvana would be being able to get to a common data platform overall, and a common data model. If I go way back early in my career, I worked for one of the 3 big credit bureaus here in the US with Equifax, but you also have TransUnion and Experian. And so even though those were competitors, eventually what happened is that entire industry settled on a credit reporting data model that was common, because even though they were competitors, it became easier for the interoperability across all the customer sets for those 3 different competitors that really own the industry to come together on a data model. I don't know if that's going to happen anytime soon in the industrials, but at least getting to open standards on the hardware and getting software capabilities that allow you to take these disparate data sets and these disparate protocols and begin to bring those together so that you can at least start, maybe not as an industry creating a common data model, but as an individual customer creating your own common data model. Those are really the keys to start to bring IT and OT together and start to really drive value.
Interesting trip. The question now is for Jared. And I would like to go back to the topic of software, right? Once again, the key enabler. Jared, would you like to highlight from an alliance perspective and the software, what's the value add that gets to the customer? Talking about, once again, alliances and software.
Sure. So I'm going to use an illustration here to focus my point. What you see here on the screen is a diagram of software architecture that we put together for a water utility in the United States. And what you can see here is that the utility is trying to bring together all of the different sites that they have to control. The wastewater treatment, the collections, the water sources, the power. Bring all of that data together. They have different reporting requirements at different levels. They have different access levels. They have IT integration with their customer database, with their GIS information. All of this has to come together. So the first step in making this all work from a software standpoint is to have an ecosystem, and Tripp mentioned the open standards and the interoperability is the number one requirement. So if everyone that's providing software in this space, and there's no single provider here, this is many different software providers that the water utility is using to accomplish this goal, they have to be able to share data. So that's first and foremost. But then moving beyond just the ecosystem, you start to think about alliances and partnerships where the different players in the ecosystem have come together. And the reason we do that is to make life easier for the customer. So in this particular example, the customer wanted to buy our software, but they needed some servers to run the software on in each of the locations, like their wastewater treatment plant or their water treatment plant. And it just so happens in this case that Stratus and John's servers were the servers they chose. And one of the reasons they chose them is because we had worked together to test and validate that our software runs really well on the Stratus Technology servers. And so when that is done by the suppliers in advance, it gives the customer the confidence that they can minimize their risk when they're trying to push the edge on their capabilities. And the more things we as suppliers can do to streamline that, to really speed up the time to results, and to minimize the potential pitfalls that may come as they're deploying new technology, that's only going to help the customer get to where they want to be faster. So I see alliances as a way that we as suppliers can work together in the customer's best interest and make sure they get to the return on investment they expect as fast as possible.
So, so we looked at alliance and software, what Jared talked about, and we are actually talking about an ecosystem, as I mentioned earlier. I mean, that's most important for this transformation to happen, or effective transformation to happen. So, John, a question is, for a system integrator who are, as I might just say, connecting the dots, right? We have a customer's requirement, we have hardware, software, alliance partners, and then understanding customer requirement and creating a right solution and deploying it, a complete process. From a system integrator, what full value they can bring it to end customer? What are the key success factor which you would like to highlight? And maybe if you want to kind of tell us about a couple of use cases to strengthen further what you're going to be talking about.
Sure, Nikhil. I'm gonna tail off of what both Tripp and Jared said with regards to solutions, and I'm using a slide here. Jared talked about some joint work we did with Aviva, and it's really to highlight some of the key points that both of my peers here have mentioned. I think we're moving into a solutions era, first of all, and it's important that we understand that solutions are going to require partnerships, and awareness of the customer's requirements, and as well standards. With that in mind, they're going to have to navigate quite a bit. They're going to broker, they're going to manage solutions that may cross over between cloud and edge, require both IT-based solutions or technologies and OT, hybrid solutions where the combined, for example, some of what we deliver with our zero-touch platform is a hybrid platform providing both operational and traditional IT technologies. So in this example, you see Aviva and Stratus with Microsoft essentially delivering a complete end-to-end solution, hardware and software, OT and IT, cloud and edge. And it's important to recognize that as we move to this next generation set of solutions, standards are critical. And there's a number of initiatives today that are driving standards across the board. Without getting into a whole lot of detail on which ones or promoting any specific ones, the intent is that there's a recognition that this complexity that's coming forward will require interoperability, and it will require more standard interfaces, both hardware and software, so these systems can come together.
So interesting insight. We looked at it. I think two questions covering fundamental topics for Industry 4.0, the foundation, the enablers, and of course the ecosystem. And that's very helpful. We would like to continue the discussion as much as we can, but we are running down the clock here. And I have one last question, and that question is same for all of you. The question is more futuristic, right? If you have to think about one or two game changer in 3 to 5 years, what that would be, and you can do a prediction, you can give your opinion. And I would like to start with Jared, and then John, and then Trip. One or two game changer, what you see for Industry 4.0 for 3 to 5 years in future.
Sure, Nikhil. Well, I'll be honest, I wish we had 3 to 5 years to think about what we need to do right now, right? In the last earnings report last week, the CEO of Microsoft was quoted as saying, "We've seen 2 years worth of digital transformation in the past 2 months." The things that we've been thinking about that were on the horizon, things like lights out manufacturing, remote collaboration, remote control of factories, all of those things are being prioritized, and there's an urgency to move that roadmap, to bring it in from 3 to 5 years out to 3 to 5 months out, possibly. So, right now what I see, and with our customers that we've been talking to, is there's 3 key areas: process, people, and technology. We have to converge all of those, and we have to think cloud first and AI enabled. And as we do that, we can start to realize more mobile and remote working environments, more autonomous factories, those types of things. And so, I think everyone knew that was on the roadmap. What I think is happening is we're pulling in the event horizon to be much, much closer than I think most people expected.
Sure, actually I agree with most of what Jared said, if not all. What I'm going to focus on more specifically are the technologies, and there's several disruptors that I think are very important for us to look at, especially in the industrial space. Certainly we are looking at a transition today where we're moving to be more customer-centric, more data and insights oriented. But fundamentally, there's still infrastructure challenges that are going to create barriers. And so when you look at technologies like virtualization and wireless specifically, those are probably the key game changers in my mind, which is basically taking virtualization-based technologies, traditional hypervisor-based, VM-based, containers, microservices, orchestration technologies. Those are powerful technologies that really haven't infiltrated industrial automation and control. And the second is essentially unwiring the machines. And there's an opportunity there to bring in some of the emerging Wi-Fi, 6G, as well as 5G technologies on the LTE or more of the remote side. So when I look at those key technologies, I think they're fundamental as we move to an era of artificial intelligence. We still need to address some challenges where I think there's still opportunity to essentially match where the industry has evolved to on the IT side.
Okay, well, with the benefit of going last on my predictions for 3 to 5 years, I get to build off of what both the gentlemen said just now. Now, I agree with both, but I actually think they played it a little safe. So I think I want to push the envelope a little and make a little bit of bolder predictions here and kind of shake things up at the end. First and foremost, I think we're going to see much more IT type solutions and IT type hardware infrastructure and even IT type protocols and standards making its way directly onto the shop floor more and more. I think that's something that we're already starting to see accelerate, and over the next 3 to 5 years, I think it's going to be commonplace that companies may even shift from creating data centers and trying to connect to the factories to actually taking these newer edge capabilities that are being created that are robust enough that can run the same types of data sets and the same types of software that normally is reserved to the data center or the cloud, and actually running them directly on the shop floor. You know, for HPE, that's been a huge focus of ours, and I think we're going to continue to see that to grow, maybe 5, even 10x what it looks like today with the amount of IT gear and, of course, the related software to go with that that'll go directly on the shop floors. And one of the big drivers for that, I think, is going to be because you need systems that can support the growth in accelerators. You know, whether it's GPUs, whether it's FPGAs, I think the use of accelerators specifically to drive either heavy data related compute, maybe machine learning and AI models, but I think more specifically video analytics, being able to use video analytics to help drive problem identification and quality assurance type use cases across the industrials, I think is going to be a huge growth. And so because of that, you're going to have way more IT gear on the shop floor, and you're going to have way more of that being driven by accelerators. You know, I also agree with the comment that was made earlier about autonomous lines, and so I actually want to take that a step further and really push the envelope to say within the next 3 to 5 years, I predict there'll be many more autonomous lines on the shop floor, in plants and in factories than we'll have autonomous cars. I know all the talk's been about autonomous cars, all these investment dollars going in, all the platforms going in. In the next 3 to 5 years, you're going to see autonomous lines in factories leapfrog that by leaps and bounds and actually being implemented and driving real values, while autonomous cars will still be things that we're testing out in parking lots. And finally, to finish up, I think something we really haven't talked about, I think augmented reality is going to be something that moves from sci-fi or a gaming type of a technology and really makes its way into industrials, into manufacturing and in utilities and these types of industries. And the reason for that is another problem that we're seeing is not just these data silos within these plants, but it's the fact that this is an aging population that are working these jobs currently. The next generation is never going to spend as much time, 20, 30 years at the same company, maybe even in the same plant, working their way up from a line all the way to a supervisor. So you've got an internal expertise gap that you're starting to develop. And with some of these newer AR technologies, you can now maybe have a few centralized experts as your role. So while you're balancing out the time it takes to roll out these new industrial IoT capabilities to really automate the plants, you're going to have a few of these resources that really have in-depth knowledge, but you're able to leverage these AR technologies so that you can have a much more junior resource in a remote location that's directly in front of the machine or the area that's having the problem. They're leveraging these augmented reality solutions, so they're wearing the goggles or the glasses or the headgear or whatever. They're looking at the problem. That's instantly beamed back to the expert. Maybe they're even at home in a retired state getting paid just a little bit on the side. They're able to see in real time, diagnose, interact, draw directly on what the end user is looking at. And so that when they're looking at it in real time, they're seeing the machine and they're seeing the notes and also potentially interacting live with that expert resource. And so this is a case where AR technology is going to make its way from the holodeck, from Star Wars, from Star Trek, and really onto the shop floors to drive real values to help our customers and these industries solve this aging workforce problem. And so that's my third prediction, is I think augmented reality is going to make a huge gain in these areas.
So thank you to all three of you on very good perspective on the game changer, and really liked it, different views and what you people think. So that brings us to end of the discussion, and I just want to go back from where we started. Industry 4.0, we referred to smart manufacturing, smart factory, machine learning, artificial intelligence, the self-healing process, and much more. And then we came on to the topic of the ecosystem, because if we want everything to work the way we expect it to work for industrial age, managing the data and the full end-to-end process, I think the ecosystem is the most important. And we have seen the different views from our esteemed panelists. So a very interesting insight. I would like to mention a couple of things over here as we close our discussion, that it is so important to create a perfect ecosystem. It's not about only one thing, and that's only about generating and managing data. It's about full enterprise, the way we manage the data, a software layer, IT, OT integration, a right way of convergence, and everyone has a role to play. Schneider Electric is very uniquely positioned as a leader in this Industry 4.0, helping the transformation, helping our customer. And we are working with our alliance partner like Hewlett Packard Enterprise, Aviva, the global leader in industrial software, and also companies like Status Technology, and creating a right kind of ecosystem to provide and to generate value for our customer, or to help our customer in their digital transformation journey. I would like to thank all the panelists for a great insight that they provide us. And more importantly, I would like to thank all of you for engaging us, staying engaged during this interesting discussion. For your patience. I hope that the discussion what we had would have helped you with a lot of insight, and I would kind of encourage you with your questions. Please do write to us. We will come back to you, all of you, with answer for your specific questions, and any insights, more insights you want, we would be more than happy to help you. And once again, thank you for your engagement.